This is IB Math AAHL Summer. Um, I know it's been about 5 months since I've posted my last YouTube video, which goes against the idea I had for this channel, which was to post every time a test was coming up. But, well, school is hard, and I had clubs, other extracurriculars I needed to do, and it was hard to find the time to make these math videos as much as I love them, because it does take a while. But anyways, I believe I left off on exponents and logs, that test, and well, really the only thing about this unit was, well, exponents and logs and polynomials, so that's what I'll be covering today. So of course I'm going to start off with the very basics of this unit, and I would actually say in this unit that these essential understandings are really what this unit is centered around, because a lot of the problems involve simplification. So the tricks I'm going to show you, you're going to need to find those tricks and problems often, and that's what's going to be the hard part about them. So it is actually very important to know these simple things. So we'll start off with right up here, log base 10 of 10. Whenever you have the log base whenever the log base is the same number as what's up here, so in this case we have 10 and 10, the answer is always 1. So let's say we have log base 5 of 5. That's equal to 1. Now, when we have log base 10 of 10 squared, or anything that's squared, or not even squared, just anything to the power of whatever, you can always take this exponent and move it out to the front of the logarithm. So in this case, we can simplify this to 2 times log base 10 of 10. And log base 10 of 10 is 1, so this is going to be 2 times 1, which is equal to 2. Now this one's a little bit different. Say you have the exponent on the base of the logarithm. Then what you can do is you can take that exponent, the inverse of it, and make it the exponent for this top number right here. So we had 10 squared at the base, and we took the inverse of the 2 and put it as the exponent for this number right here, this 10 right here. And then of course, as we just did before, we can move that exponent to the front. So we could say that this is 1/2 times log base 10 of 10, which is equal to 1/2. Now for when you have a log added to another log, but they have the same bases, whatever number is right here, you just multiply it by the number over there. So this is going to be log base 10, and 50 times 2 is 100, so log base 10 of 100. And we can actually simplify this to log base 10 of 10 squared, which is equal to 2 times log base 10 of 10, as we did before, which is equal to 2. And for subtraction, you could probably guess what it is. It's just division. So we're going to have log base 10 of 25. Now for natural logs, it's the same thing, pretty much. It's just if you have natural log 50 plus natural log of 2, that's going to be natural log of 100, and of course you just divide there, so that's going to be natural log of 25. So as I said before, a lot of this unit is being able to find these simple things, being able to find these little tricks in the problem to simplify it further. So it's really important that you know these well. Now we're just going to jump right into a problem, now that we have those basics covered. This problem right here says that log base 3 of x minus log base 3 of 5 is equal to 1 plus log base 3 of 4. Find x. Well, we can use what we just learned to find x. First, we're going to start by noticing that all 3 of the bases that we have here, they're all 3, which is very good for us. It makes this problem very easy. So the only outlier is this 1 that's right here. So we have to think, well, how can we change that so it fits better with the problem? Well, we know that any base of a number that's the same as the number on the top, when you have log base 5 of 5 as we used before, that's equal to 1. And log base 2 of 2 is equal to 1. So that means that log base 3 of 3 is equal to 1. Now this is very important because we can plug in log base 3 of 3 for the 1 right there. And so then all of our bases will be the exact same. So let's do that. If we plug in the log base 3 of 3, we're going to get log base 3 of x minus log base 3 of 5 equals log base 3 of 3 plus log base 3 of 4. Now we have to simplify this further by recognizing that when you add or subtract logarithms with the same base, it's just multiplying or dividing. So on the right side, we're going to have log base 3 of 3 times 4, which is equal to log base 12. On the left side, we're going to have log base 3 of x divided by 5. And so then we have, let's just write it all together. Log base 3 of x divided by 5 is equal to log base 3 of 12. So then we say that x divided by 5 is equal to 12. X is equal to, x is equal to 5 times 12. Therefore, x is equal to 60. There. Now I want to introduce you to one final rule of logarithms, and I don't believe this rule has a specific name. Base changing property of logarithms rule maybe. But basically what this does is it's a way for you to change the base of your logarithm if that base isn't something that works or fits well with the rest of the problem. So here you can see that when you have log base a of b, then you could say that that's equal to log base c of b over log base c of a, where c is any number that you choose it to be, as long as it remains constant for the numerator and the denominator. And then you could say that that is equal to 1 over log base b of a. So it's essentially just taking what we have here and kind of reversing everything. You put a 1 on the numerator and you flip the a and b. It's just a way to change the base of the logarithms. And you might be wondering how this is useful. Oh, and by the way, you don't have to know how to derive this. You can just I think it's in the formula booklet. But let's say we have log base 4 of 5 plus 1 over log 5 of 4. Now, if you didn't know this rule, you'd be a bit confused, right? How do you solve this? But since we do know this rule, we know that log base b of a, when you have 1 over log base b of a, then that's equal to log base a of b. So what we can say is that the 1 over log 5 of 4 is equal to log base a of b. So this will be, the a is 4, the b is 5. And so this will be equal to log base 4 of 5. So then we're going to have, if we write the equation again, we'll have log base 4 of 5 plus log base 4 of 5. And of course we just multiply the 5, so we get log base 4 of 25. So here's a problem from my test. And this was a 5-mark problem, so it's a pretty decent amount of points. I actually didn't get full marks on this. I got 4, and it's because I didn't use the base changing logarithm rule. I couldn't bring that back to mind, I guess, during the test. So that's why I wanted to do that right before this problem, so that it was fresh in our minds and we wouldn't miss it. But courtesy to a friend of mine in my class who also struggled on this, but together we were able to work together to figure the problem out. So we can see here that log 3 square root x of square root x is equal to 1 over 2 log 2 of 3 plus log 3 of 4x cubed. And x is greater than 0. We have to find x. So what we're first going to do is we're going to start with the base changing logarithm. We can see that this is 2 right here. We don't like that. Everything else is 3. See these two 3s, so we want to get this to 3 somehow. That is the first step that we should take. This, I didn't take that as my first step, which probably is why I missed that 1 mark on the problem. So we're gonna say that log 3 of x of square root x is equal to, well, we're still gonna have the 1/2, but we're gonna have also 1 over log base 2 of 3. So if we use the rule from before, we know that 1 over log base b of a is equal to log base a of b. So this can be rewritten as log base 3 of 2 without a 1 on top of it or anything, plus log base 3 of 4x cubed. So now that we have that out of the way, a lot of this problem is just simplification, like I said before, using the basic rules to simplify the logarithms. So what we're going to do first is, well, I see that there's an x here, there's an x cubed here, and there's an x here. So we're going to get those x's to one side. So we're going to say that log base 3 of x of square root x minus log base 3 of 4x cubed is equal to, and what we want to do in this problem is we want to take this 1/2 and we want to actually put this back as an exponent of the logarithm right here. Now why we're doing this is because it's going to simplify. Here, let's write it out first. Log base 3 of the square root of 2. Because now this makes this more simple, since we don't have any extra numbers. We can say that if we just write that log base 3 of x of square root x divided by 4x cubed is equal to log base 3 square root 2. Like I was saying, since we don't have any other numbers, like anything to add, anything to multiply, we can say that this right here is equal to square root of 2. Sorry, I had to pause there for a second, my mic turned off. Anyways, like I said, the square root of x over 4x cubed is equal to square root of 2. Now we can say that. So let's just write it out here. And now all we gotta do is just some algebra. We're gonna square each side to get rid of the square root. So we're gonna have x over 16 x to the 6 equals to 2. We're gonna multiply each side by 16. So we're gonna have x over x to the 6 is equal to 32, and x over x to the 6 is x to the negative 5, so we can say that x to the negative 5 equals 32, and of course x to the negative 5 is 1 over x to the 5, so we're going to say that 1 over x to the 5 is equal to 32. And if we do some more simplification, we could say that x to the 5 is equal to 1 over 32. So now, just more and more simplification. We say that x is equal to 1 over 5th root of 32, and this is equal to 1/2, greater than 0. So x is equal to 1/2. Okay, now we have polynomials. And for this, I would suppose that there's a lot of things you can know about polynomials, but for IB Math, there's really just a few things that are important to know about these. So, well, first of all, polynomial is, well, it's like a quadratic, just, oh, hold on, my Wacom tablet's the wrong way. It's just with more power. So let's say here, 3x, not squared, sorry, cubed minus 11x squared plus let's say kx plus 8. Now k, you won't always have a k, but for the sake of the problem that I'm going to use later on, there is a k, but this is a polynomial. If you just had something squared, like 24x squared minus something squared plus something, that's a quadratic. But polynomial is just when you have to the power of something greater than 2. So, like I said before, there's not that much to know. Just a few important things is that the sum of the roots of a polynomial is going to be equal to b over a. B being whatever the second highest power, the coefficient multiplied by the second highest power is. In this case, it would be 11, and a is just going to be 3, the coefficient of the highest power. So this would be equal to, in this case, this would be equal to negative 11 over 3. That's the sum of the roots. And the product of the roots, another simple equation, it's either going to be z over a or negative z over a. Now this depends on whether the highest power is odd or even. So if it's z over a, if there's an even power, if the highest power is even, and it is negative z over a if the highest power is odd. So in this case, in this example, we have an odd highest power because we have 3 right here. Odd highest power. And so this will be negative z over a, z being the final term, the one that's not multiplied by x. So this will be negative 8 over 3. That is the product, product of our roots. Okay, now we're going to start with a problem here, and if this is just part A of the problem, in part B, I'm going to go over the next thing that's important to know how to do with polynomials. For part A, we're just going to do something, this was actually from a test, this problem, that's why I wanted to do it. And this part will probably involve math that you might already know how to do, but I guess it's good to refresh them. And part B, we'll learn how to factorize as a product of linear factors, which is the next important thing, like I said, to know how to do with polynomials. But just getting started with part A here, it says that given that q of x has a factor of x minus 4, find k. Well, we know that since the factor is x minus 4, we know that if x is equal to 4, then the entire thing is equal to 0. Q of x should be equal to 0. Or sorry, not q of x, q of 4 is equal to 0. So that means that we're going to say that q of 4, which is equal to 0, is going to be equal to this entire equation just when you plug in 4 for x. So 3 times 4 cubed minus 11 times 4 squared plus k times 4 plus 8. And if you just simplify this, if you just do some calculations, we'll get that 0 is equal to 192 minus 176 plus 4k minus 8, sorry, not minus, plus 8. And this will imply that 0 is equal to 24 plus 4k. And we can say that now that k is equal to negative 6. Okay, so here we have part B of the problem. And as I said before, this is where it's more important to know about polynomials, because this is factorizing as a product of linear factors, which was one of the key things I wanted to go over for this topic. Now, when you're factorizing as a product of linear factors, and you can see I've already written out some stuff here. I just realized this shouldn't be 4x, this should be kx. But anyways, like I was saying, when you're factorizing as a product of linear factors, over here what I have underlined is a linear factor. So that means that over here, this entire equation that I also have underlined, we're going to get it to look something like this in this format, where you have x minus 4 and x plus or minus something that we don't know yet, and then again times x plus or minus something that we don't know yet. We know though that this will happen 3 times because of the 3, which is the greatest power of x that we have. It's the greatest exponent, so we know that we have to have 3 parentheses. So let's start this problem. How we do this, how we factorize as a product of linear factors, is we take the factor that they gave us and we just divide it by the entire equation. So we have x minus 4 divided by 3x cubed minus 11x squared. And since k is negative 6, we have minus 6x plus 8. And how you divide this is it's not how you might think it works. It works a bit differently than standard log division. What you do is you just we're only going to be dividing by this x, if that makes sense. So how we're going to do it is we're going to look at this first, the 3x cubed, and say how many times does x go into 3x cubed? Well, it goes into it 3x squared amount of times. So on the top, above the 11x squared, we're going to put 3x squared. And then we're going to multiply the x by 3x squared. So we're going to get 3x cubed. And then we're going to also multiply the negative 4 by the 3x squared. So we're going to have negative 12x squared. And then all of this, because we're subtracting, will be multiplied by a negative. So it'll actually be negative 3x cubed plus 12x squared. And what this will come out to be, the 3x cubes will cancel out, and 11x squared plus 12x squared comes out to be just x squared. And so from there, man, my mic disconnected again. But let's get back on track. So, like I said, 3x, I was over here. So if you subtract everything, we have x squared. Now we're going to bring down the negative 6x. And now we're going to do the same thing. So let's see, how many times does x go into x squared? Well, that's going to be x amount of times. Let's just put the plus right there. And how many times, not how many times. If we multiply x by x, of course, that'll be x squared. And if we multiply negative 4 by x, that's going to be negative 4. And everything is multiplied by a negative because we're subtracting. So the x squareds will cancel out, and you'll have negative 6x plus 4x, which is going to be equal to negative 2x. Now we bring down the 8, that we have plus 8. How many times does x go into negative 2x? Goes into it negative 2 amount of times. So let's multiply. You'll get negative 2x, and then negative 4 plus negative 2 is equal to positive 8. Everything is multiplied by a negative, and everything will cancel out. So what we're going to do from here is actually I'm just going to first draw a box just to separate everything. And okay, now we're going to take the equation that we got when we were dividing, so the 3x squared plus x minus 2, and we're going to factorize it. There are a few ways that you can do this, but we're going to do the factorizing by grouping. And what this is it goes that if we take the number here and the number here, so 3 and negative 2, we're going to multiply them by each other. So we're going to say that a and b multiply, when you multiply, it gets you to negative 6. But when you add them, a plus b, it gets you to the middle number, which we don't have, so that's actually just going to be 1. And so we have to think, well, what numbers do that? And luckily in this case, it's actually just a is going to be equal to 3, and b is going to be equal to, actually that's about 3. B is going to be equal to negative 2. So from here, what we're going to do is we're going to separate this equation now, given that a is 3 and b is negative 2. And what I mean by that is that, let me draw another box actually. We're going to separate it by doing this. We're going to say that it turns into 3x squared plus 3x minus 2x minus 2. And you can see that if you add the 3x to negative 2x, it comes out to be x, just like we have over here before. But we separated it, so now we can factorize this portion and this portion individually. So first we're going to start off with the 3x squared plus 3x. And what can we take out of that? Well, we can take out 3x. I was about to say 3x squared. We can take out 3x. And what we'll be left with is x plus 1 in the parentheses. Now for the negative 2x minus 2, we can take out negative 2, and we'll be left again with x plus 1. You see, this is why we separated the 3 on this side and the negative 2x on that side, so we'd get x plus 1 in both their parentheses. And so all of this can simplify to 3x minus 2 times x plus 1. You can see we just took the 3x from here and combined it with the negative 2 from here. And so now we get this as a result. But now we have to go back, all the way back to the x minus 4. It's been a while since we've worked with that. And we have to multiply it as well by x minus 4. So we're going to get x minus 4 times 3x minus 2 times x plus 1. And so our final answer, when you factorize, and actually let's again make another box. This will be the end result. This is the answer to our question. When we factorize this entire equation, 3x cubed minus 11x squared minus 6x plus 8, we are going to get x minus 4 times 3x minus 2 times x plus 1. And all of these three things are products of linear factors. Or not products, but they're linear factors. So we've just factorized this equation as a product of 3 linear factors.